and 3.4 over slope. So when we're looking at slope, we're talking about the rise and the run of a line, so how much it goes up and over. So if it's going up like this, that is what we call a positive slope. If it's going down, and we always read from left to right, then it's negative. And I'm just writing it like this because that's how I remember it. Up ends with a P, so it's positive. Down ends with an N, so it's negative. And you read it like a book from left to right. This is a vertical line. This is horizontal. This one has an undefined slope. Because it has rise, but it has no run. And since slope is rise over run, if the run is 0, you divide by 0. And in math, you can't divide by 0. So that's why that's undefined. But this one has run, but no rise. So the rise part is 0, which means that the slope is just 0. Then we have the equations. This is just y equals some number. This is just x equals some number. All right, so here is your slope formula. You're just subtracting the y's and putting it over the x's. You just got to be careful about making sure you put that in parentheses or just solve it in your head. That's what's best in my opinion. All right, what is the slope of a line through these points? So let's see, we need to do y2 minus y1, so negative 5 minus 3, all over 7 minus negative 1. So this is basically like plus. So negative 5 minus 3 is like plus a negative 3, so that's negative 8. That's positive 8, and you get negative 1 for the slope. Oh, sorry. Okay, you pause it and try this one. Now you can type minus a negative in your calculator, but it ends up just being plus. So 6 plus 3 is 9. 4 plus 2 is 6, so that reduces to 3 over 2. Which is also 1.5, but we always do slope in fractions because you do rise over run and it's difficult to do up 1.5 over 1. So when you're finding slope from a graph, you always put the rise on top and the run on bottom. So first we decide from left to right if it's going up or down. This one's going down, which means the slope is going to be negative. Then the rise is how much it goes up from one point to the other. So that's 1, 2, 3, 4, 5 up and over 1, 2, 3. The 3 is the run, so that would be negative 5 over 3. All right, so hopefully you remember this from algebra. Y equals mx plus b is slope-intercept form of a line. So the x and the y is just some point on the line. We usually just leave that as x and y. M is the slope, and b is the y-intercept. That's where it crosses the y-axis. All right, so on this one, I think this is the one we just did, up 1, 2, 3, 4, 5. Over 1, 2, 3. So the slope is negative 5 over 3. The b, that's the y-intercept, that's where it crosses the y-axis. So it crosses at 1. So you end up with y equals 1x. Oh, I'm sorry, that's not right. Negative 5/3 x plus 1. That's a big deal. Perpendicular lines theorem says two lines are perpendicular if and only if their slopes are opposite reciprocals. Opposite means if one is positive, the other is negative, and vice versa. Reciprocal is like a flipped fraction. So you basically flip it and change the sign. So if their slope was negative 1/2, then the line perpendicular that would be positive 2, because it's like 2 over 1 when you flip it, and 2 over 1 is just 2. So if we are finding the whether these lines are parallel, perpendicular, or neither, we need to be looking at their slopes. So if they are parallel, they'll have the same slope. They're perpendicular, they're opposite reciprocals, and if they're neither of those things, then they're not parallel or perpendicular. So we do y1 minus y2 over x1 minus x2. So that becomes plus, so we get 2 over 0. Now you cannot divide by 0, so anything divided by 0 is undefined. That means it's a vertical line. So then we have 6 minus 0 over 0 minus 0, 6 over 0. That is also undefined. So we have two vertical lines, and those would obviously be parallel. Then we get 3 minus 1 over 3 minus 1. It's 2 over 2, which is just 1. Then we have 4 minus 2 over 0 minus 2. So we have 2 over negative 2, which gives you negative 1. Now they're not the same, so they're not parallel. And opposite reciprocals, when you flip it, it kind of confuses people because this isn't flipped, but really it is, because a whole number you just put over 1. So like if you had, 4, that's like 4 over 1. So when you flipped it, it would be 1 over 4. So 1 over 1 flipped is still 1 over 1. So 1 is the only one that looks exactly the same, but just the negative. So that is perpendicular. So pause it and see if you can try these. So you get negative 1 over negative 3, which a negative divided by a negative makes it a positive 1/3. So you end up with 2 here, which is neither. And we do 2 minus negative 2 all over 1 minus negative 3. Sorry, you get 4 over 4, which is just 1. 6 minus 3 over 4 minus 1, you should get 3 over 3, which is just 1. So those are parallel. Looking at y equals mx plus b, the m is the slope, so if we're looking at this looking for the slope, this one's really easy, you just get 1/5. That's the slope. But most of the time it won't be that easy. You'll have to actually solve for y, so you get y by itself. Start by subtracting 6x here. And I always write the x first to make sure it's in this form, just because it's more helpful. Then you'll divide by whatever's in front of the y. So we have y equals negative 3x plus 17 over 2. So your slope is negative 3. So pause this and see if you can do these. I'd move the 12 and just leave the y on this side. It doesn't matter if it's on the wrong side. Because of the symmetric property, you could just flip it if you wanted. So on this one you get 1/2 x minus 2 equals y. So the slope is 1/2. Then on this one we subtract 8x. 2y equals negative 8x plus 20. Divide everything by 2. Should get y equals negative 4x plus 10, and the slope is negative 4.